Hello, it's Mr. Koi. So here I am with some light bulbs going over the parallel and the series of this. So first I want to just notice that these are no different, the setups. We have one battery, some wires, two light bulbs, and we have one battery, some wires, and two light bulbs. But if I plug both of these in, you'll notice despite having the exact same materials, we get a very different result. And so even though it's not super easy to see because the camera has a hard time picking it up, clearly these are brighter. So let's talk about what's going on here. So that we can see it better, I turned the other one off, but you'll notice the way they're connected. So these right here are connected so that they're holding just one hand right here. So they're in a row. We call these series. So just like you watch a TV series, it's one after another. You watch them in a row. Parallel, on the other hand, is kind of like your math class, right? Parallel means they're next to each other, but they don't actually touch. So these are next to each other, but they're not actually interacting with each other. They're only interacting with my battery lines, which are these things on the outside. So we call these series and parallel. And the interesting thing to notice is we have the same tools, but the parallels are very obviously brighter. And this has to do with how the energy is being distributed. So we've been talking about energy and voltage and current and resistance. So we're going to take it to the whiteboard really quick and show you what I mean. So my cardboard stand. So when we're talking about this, when we're talking about series and parallel, this is the way we draw them. So a basic series circuit has a battery, a positive and a negative side. I'll draw that a little larger so it's a little small to me. And it's one light bulb after another. So we draw a light bulb and a light bulb, and then there's our wire going back to our battery. And then if we look at our parallel, if we were to draw a circuit for our parallel, notice they are parallel, as the name suggests, and not one after another. So again, this is called a series. And this is called a parallel. When we're doing these, so I was using a 9-volt battery, so I'm going to make this a 9-volt battery by using the power of imagination and writing 9 volts right here. Interesting. My pens have all decided to hate me. So we'll make this a 9-volt battery and this a 9-volt battery. So 9 volts in a battery means that's not the total energy, that's how much energy each charge or unit of charge carries. So we can say that our electrons that are traveling down the line, and so some go this way, because remember, why would you go backwards when you could go to the place you always wanted, which for the electrons is to the positive side of the battery. And then some decide to go the other way. In a series, all of your electrons are only going one way. Because there is only one way. There's only one way to get home. Each electron gets to carry 9 volts with it. That's a way to look at how much energy each electron gets. And so I made a mistake here. Because it takes energy to get through a light bulb, right? Because the light bulb is giving off light, it's giving off heat, it's giving off energy. And that energy comes from our electron. And so since we have two light bulbs here, and it only has 9 volts, it's going to spend half on one light bulb, half on the other light bulb. So it's going to have 4.5 volts when it's in between. But once they get through all of the light bulbs, we're going to have no volts left. They're tired, they're done, they're ready to go home. Parallel, however, even though I have 2 light bulbs, no electron has to go through both. Each electron only has to go through one. Because if I travel this way, I don't have to go through this light bulb. And same thing, if I go this way, I don't have to go through this light bulb. So each electron still starts with 9 volts. But since they only go through one, all of their energy is released at that light bulb. And so we would say, we call it a voltage drop. And so each one of these only has a voltage drop of half of 9, 4.5, where each one of these has a voltage drop of 9. And that's why these are so much brighter. Well, it's one reason, there's a couple more. Because each light bulb gets more voltage. But there's another reason. Because you also want to think about these are flowing, moving electrons. And if you've ever driven in traffic, I mean, it's the Bay Area, so we've probably all been in traffic. Does traffic flow faster when there's one lane or 2 lanes? Hopefully, you know enough about traffic that it flows much better when I have 2 lanes. And electrons are the same way, because instead of it being crowded, they can spread out, they can go faster. So just like our cars, we call this flow, remember we call this current. So because there is less resistance, so more lanes equals less resistance. And if you're not resisting, you're gonna get a better flow. So more flow equals more current. And this is the second reason why it's much brighter. So because each light also gets more current. So the reason why these parallel ones are brighter is a twofold reason. 1, each gets more voltage, they get more energy. 2, they get more energy per second because there's more electrons moving through each one per second, because if the traffic is lighter, if the electrons aren't clogged up, they can move faster, and they absolutely will. So whereas this one, a lot of resistance, they're going to move much slower. All right, this concludes a little short demo and explanation of series and parallel. Hopefully it was helpful, and have a good rest of your day.